Howdy, IB. It's Miss Kosh. I want to talk through a few things about functions so that you can practice some of the problems from the book and be good to go. So first of all, I hope you realize that a function is a relation where each x has exactly one y. Okay, so it could be that we've got a graph that does something like this, and we would use a vertical line test where we want to make sure that for every x value, it only hits in one spot. Okay, so for every x, there's exactly one y. We could also look at the situation where they've given you a set of points, and so we have like 1, 2, and we have 3, 4. If you have something like, and it gives you 1 and it assigns it another value, this would not be a function because 1 is being paired with 2 and being paired with 5. However, if you have the points 1, 4, and then the point 2, 4, this would be a function because you've got the point 1, 4, and then you've got the point 2, 4. So your x was paired with exactly one y. It doesn't matter if they're paired with the same y. Okay, so hopefully you're aware of that sort of thing. One thing that the IB book does that you might not be familiar with it, or it's not just an IB thing, but we know that this is the function f. This is f of x is how we say that. And so this is the function f. If I said this is equal to x squared minus 5, I don't know. Then this function f, each x is mapped onto the y value that is found by saying x squared minus 5. Well, that's function notation. This is what they call, but sometimes what they do is they'll use mapping notation. And that looks something like this. F is the function where x is mapped onto x squared minus 5. So it looks different and it looks weird, but it's exactly the same thing. So don't worry about that. It's just saying that you could make a column, you could have your x value and then your y value would be x squared minus 5. The x value is mapped onto the y value of x squared minus 5. So the notations, they look different, but they behave in a very similar way. Next thing I want to look at, let's say, let f of x equal, I'm doing the example out of the book plus a little. If f of x is equal to 5 minus x squared, the first thing that they ask us is to find f of negative x. So what we need to do is we're going to take this function. Actually, let me do this for a second. I'm going to use the same color. I'm going to be deliberate with my color. So this is f of negative x. That means anywhere I saw x before, I now plug in negative x. Okay, and then when I clean that up, I end up with 5, well now plus x. Negative squared becomes a positive, so that's still minus x squared. So f of negative x becomes 5 plus x minus x squared when we're given that original f of x. They also said, okay, now find f of x plus 2. Well, you know what? I can't be consistent. They now said, find, let's use green, f of x plus 2. So what I have is I've got this 5 minus something squared, and I'm going to come along and say, well, that something is x plus 2. So wherever I had x before, I now have x plus 2. And so this cleans up to be 5 minus x minus 2 minus, we know how to FOIL, this becomes x squared plus 4x plus 4. If you don't know how to FOIL, come see me. Let's clean up our terms. They haven't been in standard form, but I like standard form. Let's go with the biggest. And then I end up with a negative x, negative 4x, and another negative x is a negative 5x. This becomes a negative 4, a negative 2. It's negative 6, and a positive 5 is a negative 1. So there's that one. Then the next one, we're just cruising along. What happens if they say f of, let's use a new color. How about purple? F of, this one was in the book, f of x minus 1 minus 5. So then what that means that we do, actually, hang on. Let's use another color too, just because it's fun. It's the little things, right, as we make it through this silly time of quarantine and whatnot. Okay, f of x minus 1 minus 5. Okay, so the first part here is f of x. Well, f is this. Oh, I don't know what I'm doing. Minus something squared. Well, okay, so let's use the something is now x minus 1, but then we also have a minus 5 at the end. Okay, so when I go to clean this up, okay, where am I? We end up with 5 minus x plus 1. This becomes a minus x squared. It would be a minus 2x, but with the negative out front, I'm doing two steps at the same time. This would be a plus 1 times the negative out front is a minus 1 minus 5. So what do I see? I see a negative x squared. I see a positive x. The 5's cancel, the 1's cancel, and so that's it. Now I'm done. The last one I want to do is, and this is very important. I can't remember to change my color. There we go. This one is really, this is foundational for calculus. So f of x plus h. So we need to be familiar with how to plug in x plus h and clean that mess up and whatever. It's hugely important when you get to calculus, or the calculus part of IB, because it does come, just not today. So here we go. We had 5 minus something squared. Is that still my, yeah, okay. And what I'm plugging in is an x plus h. And so this would now equal 5 minus x minus h minus x squared. This becomes a plus 2xh, so it's now a minus 2xh. And then this becomes a minus h squared. Do we have any like terms? Not really. You could leave this one just like that. The whole point of it is that we're going to do f of x plus h minus f of x all divided by h. And then when you get to calculus, what we're going to do is we're going to take the limit of that as h goes to 0. So don't worry for right now about that part. If you've already seen the calculus, fantastic. But that's why we want to practice. We need to practice this part so that when we see it, when it's just this little piece of the whole component, you're good at it. At this point, I'm going to stop the video and let you go practice the book problems. So go work hard. Let me know if you have questions. Okay, bye.